Hello, good morning, good afternoon, and good evening. My name is Bhoopathi Rapolu from Cyient. I have 20 plus years experience in the industry, particularly geospatial, data analytics, and digital solutions. It's my pleasure to be here on this forum, and I'm going to present you our solution on utility right-of-way risk management. Let's jump right into it. So right-of-way risk management is different problem to different types of people in the utilities. Talking about vegetation managers, transmission line engineering folks, environmental compliance folks, field engineers. But in a nutshell, it's about risk to the assets. So T&D networks need to be protected from encroachments, natural aging, calamities, and anything that can cause damage to the power supply, keeping the lights on. And historically, utilities have been depending on manual inspection of right-of-way assets. That leads to higher costs and risks of outages. So we've been talking about digitizing and building 3D virtual networks or building digital twins to manage right-of-way assets to a certain extent. There are various ways of managing it. Cyient has taken a unique approach in building the digital twins for utility networks at a large macro scale, as well as at an individual asset level, from the transformer to a particular specific asset level. So depending on what kind of problem we are addressing, digital twins range from an individual asset like transformer, or a group of assets like a substation, or an entire network for thousands of miles of transmission and distribution networks. Cyient has been in this industry for nearly 30 years, delivering digital solutions at a macro scale as well as micro scale and asset level, individual machine level. So we have taken a unique approach to build digital twins for utility industry. So today I'm talking about a macro scale digital twin, that is building a parallel digital or a virtual network of utility distribution and transmission network. So depending on what kind of problem we are solving, we need a diverse set of data to build a digital twin. So for example, at a really large scale vegetation management, we need satellite data across, let's say, 10,000, 20,000 miles of networks to identify large scale vegetation encroachments. For more focused or accurate assessment of vegetation risks or any other risk posing to the network, we need aerial imagery, fixed wing or rotary wing aircraft, or even more high resolution imagery for identifying individual assets on the towers. For example, transformers, reclosers, switches, we need drone collector or UAV collected imagery. And further down, particularly in distribution scenario, we suggest collecting mobile LiDAR and imagery for identifying specific attachments on the poles and measuring to sub-centimeter accuracy. So the second aspect of it is building the 3D virtual network after collecting this imagery. So today, the computing power and the processing power has increased significantly. So it is now possible to process humongous data into required 3D virtual network, aka digital twin, pretty fast and fairly easily. And the third step is exploiting this data, building business applications for vegetation encroachment analysis, PLS CAD modeling, identifying any kind of compliance issues like environmental regulatory compliance issues that I'm going to talk about soon. So data acquisition is the predominant precursor for building digital twins at a macro scale. LiDAR and imagery take a key step in that. LiDAR for precise measurement of assets, imagery for giving the context and building the providing the real world view of the digital twin. LiDAR processing has come a long way since it was introduced a couple of decades ago. Today, we are able to process LiDAR fairly automatically thanks to the emerging machine learning technologies. So things like ground separation, clustering, classification of standard assets such as poles or conductors can be done fully automatically. That helps us in processing the LiDAR data, thousands of miles of network in a matter of days and probably a week or two, rather than months that we used to take before. When the LiDAR data is fully classified, we can use that into building the digital twin of the network. Cyient has built a platform on top of SD technology, wherein we ingest the processed LiDAR and imagery into this virtual platform that generates digital twin of the network in a matter of hours and provides a virtual network to end users. So when the digital twin is ready, building applications on top of it becomes far easier. Applications such as vegetation encroachment analysis, sag sway analysis, PLS CAD modeling, and even asset identification. For example, identifying the poles and their uprightness. For example, a pole is leaning or upright, or a specific individual attachment such as insulators, transformers, enclosures can be identified, enumerated, and even we can detect the condition of those assets that I'm going to demonstrate in our solution shortly. So you look at here, if we are able to collect high resolution imagery, preferably using UAV or mobile LiDAR and imaging, we can actually use that high resolution imagery for automated asset detection and condition assessment. These are specific machine learning models built for identifying a given asset, be it an insulator, be it a transformer or a recloser, etc. We also detect specific information from the ground assets, such as pad-mounted transformers, anything that you see on the ground. The programs can be focused at identifying the type of the asset. It's identifying number, make, and any kind of regulatory text written on those assets. Looking at that, we have built use cases around transmission network in terms of identifying various assets, as you see here, insulators, conductors, ground bonds, all the way to marker balls that you see on the large transmission networks. As I said, the features include first detection, and then the enumeration, how many of them you see, and the specific condition. Asset condition can be identified whether it is broken, flashed in case of insulators, connectors in good condition, or it is broken. So depending on the type of condition, we can program and identify automatically. coming to the distribution assets, it's mostly about identifying specific assets and reading the text on that. Assets include transformers, fuses, switches, capacitor racks, poles, etc. Sometimes even the top of the pole caps can be identified and detected. So these are the use cases we have built using our solution. Let me give you a quick demo of the solution. So the digital twin that we built is totally cloud enabled. The solution is delivered on the cloud to any compatible device, a browser-based device, tablet, phone, or laptop. This gives further wide access to the people in the office and also on the field. This is a data-heavy solution. LiDAR is heavy, but it is totally optimized for rendering or the browser to a user, whether it is well connected or connected through a mobile network. So as you see here, what you see is the network of transmission. I'll also show distribution network shortly. So here, the transmission network is modeled, can be viewed in 360 degrees. And what you see as a layer here is the vegetation encroachments. So, depending on the configuration you set. For example, you can define your thresholds like 15 feet, 20 feet, 25 feet for radially from the conductor. Based on that configuration, the reports will be generated and available for viewing here. So a plethora of parameters are available here. If it's a grow in, fall in, what kind of volume needs to be cut. Here, as you see, we provide the specific amount of volume within a tree that needs to be cut, whether it's a priority 1 or a priority 2 or priority 3. And the same thing is available here in the report as well, both in the map and the report. And I can look at any parameter and sort it. So if I sort it by volume, I want to know what is the tree that requires to be cut, that has a maximum volume in the pack. So I can click on it and fly over to that particular section of the span where the vegetation encroachment is the highest. And I can record the details of that. So though this looks like a small tree, but in terms of encroachment, it is the highest, one of the biggest volume that need to be cut. And this is just for the as-built condition. Now we have also generated the PLS CAD modeling and loaded on the same application, which can be available for viewing on the browser. So I can go ahead and add that network here. Let's say if I add the max sag condition, I can look at how these encroachments change in the max sag condition. So sag condition can be viewed horizontally, side by side. So some of the encroachments in priority 2 would become priority 1 under max sag conditions because of the difference in the height. So max sag conditions totally change the perspective of the vegetation encroachments, especially for this transmission structure. I can also see max sway condition in this that it will load. So this is now the max sway condition. Look at from the top. While it loads, I will also switch it on the LiDAR data. So this will show me in a LiDAR context how the data is looking. Yeah, so this can be extracted into Excel or PDF report. I can choose either the span that I see in the map or the entire circuit. I can choose and export, generate into a report. When it is done, I can look at the part of the network that generated, and the report is available. Apart from that, I also see the same kind of reporting available for buildings, rail network, road, water, various forms of potential right-of-way impediments. Another interesting feature is the defective assets that I was talking about in terms of identifying defective components by using preferably UAV collected or any kind of high resolution imagery to identify the specific attachments and their condition. So here's a report generated for defective insulators. I can click on any of that and then fly to the section. So I see here that there is a set of insulators that are defective. I can navigate through and then click on this insulator. So it says it's a porcelain insulator. It is a defective one. The ID and a lot of parameters are available. I can view the specific image. This is flashed here. So again, the same thing can be exported and further action can be taken. We also have pole lean detection, part of again using the imagery to identify an asset and then measure the condition. And there is a report. I can export this report or fly to a particular pole. So I can maximize my window size and see the details of the pole height, longitude and longitude here. The other interesting aspect is the audit. If I capture multiple instances of the data, that can be loaded into the same platform and detect all the changes. So change detection is one very important aspect of the network management using digital twins to identify changes, both positive and negative. For example, if the trimming is done, after that post collection would enable us to identify the QA, QC of the work done. And also the network changes, any new build, modifications to the existing build, all that can be automatically exposed. And also any natural calamities damage the network, that can be identified as well. So the change detection would automatically expose changes in the power network, as I mentioned, vegetation and building observations, road network changes, water bodies, all this will be automatically flagged and identified here. We also have an integration with work order management systems to post this into a work order management system for subsequent operations. Quickly, I will go through the distribution. So similar platform, pretty much everything remains same. Just that it is for a distribution network. We use both the aerial and also mobile LiDAR and imagery for building the digital twin of the distribution network. Here again, you can see each and every asset is modeled and their attributes are available in the system for visualization. and encroachment report is available. Apart from that, if you really want to see any particular measurement, everything is measurable here because there is a LiDAR behind. So I can measure how far is the vegetation from the conductor. I can also measure the volume. For example, if I want to see how big is this tree, how volume can be measured in area. So height of the conductors, height of the poles, and minimum distance, all those things can be measurable in XYZ. So we've used this same data for multiple other purposes apart from the vegetation management. One is the PLS CAD modeling, and max sag and sway conditions have been modeled and rendered without having PLS CAD license. You can actually view this data on the browser. The other thing is that we used the same data for identifying environmentally sensitive places, particularly in transmission scenario. We have used this for identifying wetlands, vegetation, riparian vegetation corridors that are environmentally sensitive, that needs to be protected as per some local specific regulations, and provided in the same platform so that utilities can use not only for veg management but also for regulatory compliance. The platform provides a dashboard where you can see all the metrics that you want. This is totally configurable. If you want to see just only the encroaching trees or hazardous road crossings or any other type of report that you can see here, and you can navigate it from there to a particular network. So having said that, I stop here, and I'm happy to answer any questions you may have. And thank you so much for your time. Please let me know if you have any questions.